In this problem, we are going to propose the synthesis of 2-pentanone from 1-chlorobutane. So let's draw the structures first. I'm starting with 1-chlorobutane, so 4, 1, 2, 3, and 4, and I'm going to have a chlorine here. And I need to make, so I'm going to do this, so signifying I have several steps. And I'm going to make 2-pentanone. So 1, 2, 3, 4, and 5. That's 2-pentanone. So let's number the carbon atoms. So 1, 2, 3, 4, and 5. And here you have 1, 2, 3, and 4. So what we see here is that we have one more carbon. So we need to add carbons to the chain. And what we learned in the alcohols and phenols chapter is that we can use Grignard, and that's one powerful reaction to add carbons to the chain. We're going to be using that. But we know also that Grignard reactions, these are strong bases, strong nucleophiles, that we can use to attack on aldehydes, ketones, esters, and so forth. Whenever you do that, we're creating an alcohol. But the final product, even though I can add carbon with a Grignard, say that I'm using, adding one carbon implies that I'm using well, first, say metal bromide, and I put that with magnesium and dry ether. Bottom line, I'm making metal magnesium bromide because I want to add one carbon to the chain. But if I do that reacting over an alcohol, over an aldehyde or ketone, I make an alcohol, and that's not the final product. We will need to oxidize. So first of all, to be able to attack on a carbonyl compound, I need to transform that into different compounds. So we are going first to do a substitution reaction. And here what I'm doing, I'm using, for example, NaOH. What I'm doing here, this is a strong base, strong nucleophile. So here what I'm doing is an SN2 reaction. So you're going to have that nucleophilic attack over to carbon 1. And that's not a chiral center, so not relevant that we put any configuration. We're going to make that alcohol, and that is 1-butanol. But again, I want to add carbons. So I need to transform that into a carbonyl compound and then attack with the Grignard. So what should I do to transform that into a carbonyl compound? So I want to form an aldehyde, or in that case, to be able to attack. So, but remember that primary alcohols, these are primary, and you use a strong oxidizing agent such as Jones. Say this is primary, and you use Jones. This will oxidize to a carboxylic acid. So here, if I don't want the carboxylic acid, I need to use a mild oxidizing agent. In that case, there's different reagents that I can use for that. I can use DMP, or I can use PCC or Swern. All of those will produce an aldehyde. Again, you cannot use Jones's chromic acid, and you will form it by sodium dichromic and sulfuric acid, or chromium trioxide and sulfuric acid. But here you want to use an oxidizing agent that is not as strong, so that this stops at the aldehyde. So now I'm going to draw the following. So let's say that's my reaction 1. I did a substitution. Reaction 2, I'm going to oxidize the alcohol to an aldehyde. So that's butanol. And then I can make it react with metal magnesium bromide, and this is what I'm doing. So next step, I'm going to do metal magnesium bromide, because I need to be adding one carbon to that chain. So this, I'm attacking here. And that will form, here's an alkoxide, to negative charge, and I have that metal. So now we're not there yet. What do we need to do? After the Grignard, you always have a step in which you need to protonate the alkoxide and form the alcohol. And this is your alcohol. And now you have 1, 2, 3, 4, 5 carbons, which is what you needed. How do we go from 2-pentanol to 2-pentanone? So that is an oxidizing. We need an oxidation here. And here you can use any oxidizing agent. So always secondary alcohols will be oxidized to a ketone. You can use any of those, but typically we can use here John's, and it will give you the same. So I'm gonna say that I'm forming chromic acid by the reaction of sodium dichromate with sulfuric acid. And that will create my oxidizing. So, again, the first step that we did in this synthesis, first we need to draw the structures of a compound. Here we figure out that we have 1 more carbon, and I can do that with Grignard. To add 1 carbon, I can use that, but that attacks on aldehydes and ketones, right? So, and now I needed to replace that chlorine with an OH to make the alcohol. How do I do that? That's an SN2 reaction with sodium hydroxide. The primary alcohol must be oxidized with a mild, oxidizing agent such as DMP or PCC or Swern. That'll give you the aldehyde. So let's do here primary alcohol. This is an aldehyde. And that aldehyde is attacked by methyl magnesium bromide to give you a alkoxide, then protonated to a secondary alcohol. And secondary alcohols by oxidation always give a ketone. And here you can use any of those oxidizing agents to accomplish that.